So now I want to do the beginning of the third problem here. So I'll do the beginning part for you, and then you should be able to get the other ones. It's very similar to the one we just did with the 7-ball and the 8-ball. So let's say we have a car at rest here, and we want to know its initial momentum. Easy. Mass times velocity, but it has no velocity, so it has no momentum, and so its initial momentum is simply 0 kilogram meters per second of momentum. They then tell us that this car is pushed on with a force applied of 4,000 newtons, and that's to the right, they say forward, for 4 seconds. So now we can come up here and we can find the impulse, because impulse is force multiplied by time. And so if we do that, we get 4,000 newtons times 4 seconds, and so 16,000 Newton seconds will be our impulse. And by the way, if you enter this into the computer, put 16,000 in there. So on the change in momentum, we know that instantaneously it is always the same as the impulse. Impulse equals change in momentum. So this is also 16,000. We just tend to write it with a different unit, although it's really the same thing. 16,000 kilogram meters per second is our change in momentum. So what's our second momentum here? Well, we changed by this amount. We started at 0, we went up by this amount, so this must be 16,000. Now it is important to note it's the change technically, but since we started at 0, if we change by 16,000, we'll wind up at 16,000 kilogram meters per second of momentum there. So then to do the last part then, they say after that there's a new force of 6,000 newtons for 3 seconds. So you should be able to, using the same technique, find the impulse over here. And that will give you the new change in momentum. So remember, whatever that number is, that's how much it changes. So it'll be that much more than this. So it will change this by that amount. And then the last little tip for finishing problem 3 of that next set of problems is that the last force is a brake. So it's going to be to the left. So it's going to be negative, since velocities and momentums are vectors. To the left is negative.